Michael.
And I'm Raymond.
And we made the sound Crapifier.
The term was coined by the famous Phu Woodson about a good 2 hours ago.
Yes. Originally we planned to make a trumpet sound effects pedal, but we'll get to our ADC in a little bit. But essentially, we didn't have a good enough ADC in the end, and kind of just has an effect where it makes everything sound worse, but with an effect. So that's where the name comes from. So what this is a real-time sound effects system with multiple effects. So we have a delay effect, we have an echo effect, a robot effect, a flanger effect, and a distortion effect. And most of them work as expected, but there are a few that don't really show those sound effects. But Ray will go ahead. Oh, and actually no, I got the beginning. So first what we do is we speak into a mic. We had actually a pretty nice mic in order to, because we thought we were going to be playing a trumpet into the mic. So we needed something that could pick up frequencies pretty well around a trumpet's frequency levels. We just got a vocal mic that could essentially pick up those frequencies pretty well. And we fed that mic into an amplifier because the mic has a really low output voltage. And we had to shift the signal so the ADC can essentially convert the signal to digital values. And then we sent that into the Arduino. And
yeah, so basically, by the way, you're supposed to click through.
Oh.
But the Arduino is essentially implementing all of the sound effects that we have. They're done basically using linear difference equations implemented using algorithms. So that way it'd be a lot simpler to do and cheaper. And so we have basically a filter for all 5 of them, and we have a button that basically it lets you select or toggle between all the different types of effects, and also like a setting where you don't have any effects on. We then have let's get the output signals. Oh, we forgot to put the DAC, but there's a DAC in between here. And that gets, after it gets converted to analog, it gets sent to the filter, or various filters that basically reduce noise, smooth out the signal from the jaggies that appear from converting it to analog, and also removing the DC offset, so when we send it to the speakers, it can play it properly. And then we have the signal attenuator. So when it comes out, the maximum volume or the maximum voltage signal you can get is about 5 volts, which is quite high for a speaker. Speakers run maybe around like 1 volt or less. 1 volt's kind of pushing it for general speakers and such. So we had to drop it down to at most 1 volt, maybe about 0.8 volts or so. And that leads us to the buffer. And this was to basically reduce the loading effect of the speaker, because the speaker has a very low impedance. Its range is around 30 ohms or less. And so the buffer basically is just an op amp, so it has a low output resistance, so it makes it have a better effect.
And project difficulties. There were a lot of them. But first of all, you can go ahead and start with the first one.
Yeah, so we had multiple ADC problems. Well, first of all, the onboard ADC is not good enough for audio signal processing, so we had to go buy a new one. And the new one we got was okay. It kind of did the job, but it wasn't as clean as we'd like it to get. So, and that's the one we're currently using right now. But then we were able to borrow a much faster one that could sample at about 1 mega samples per second. And the problem with that one, there's very bad data sheets for it, and because it was basically a PMOD chip, so it had 2 ADCs soldered on it, and the ADCs had different specs voltage specs than the actual chip. So the actual chip could only run at about 3 volts, but the ADCs could run at about 5 volts or so. And so we got the specs mixed up, and it kind of burns out.
We think it burnt out. It doesn't work.
It kind of revives itself sometimes, but it wasn't reliable.
Yeah. So another problem we had was just implementing digital filters in general. A lot of it we just kind of had to learn on the fly because we didn't really have much experience with digital filtering. So, of course, this whole course is designed to teach you this, and we had to try and shove a lot in about 2 weeks. So,
Talked about the speakers already. Had a lot of noise issues. Noise kind of came back up and around, and filtering helped a little bit. But
essentially, one of the problems with noise was ground loop. We were getting a low 60 hertz. We were getting a 60 hertz noise signal that would be really loud, and we weren't sure what it was coming from, and we weren't sure if it was our filters that weren't doing the correct job. But eventually, we were able to look it up and find that the noise we were receiving resembled ground loop, and it was because we had, well, one reason we think is because we had the outlets of different commercial products, or we had them plugged into different outlets, which could potentially cause ground loops. And finally, interfacing with commercial products was a little difficult because we didn't have all the specifications. We couldn't really see everything about the internal qualities of each product. So a little bit we had to tinker around a lot and try and guess and see how we need to interface everything and make it all work.
yeah, so basically, for future refinements and updates, well, one, we want to get a faster ADC and a DAC. So when we had the faster ADC, the 1 megahertz samples per second one, it was sampling pretty great, but it was like a little bit limited by the DAC. So some of the higher frequencies we were having a little trouble with. Yeah, so having a faster DAC would help with that too. And
We would also want to implement a digital noise filter because we have analog filters on our board, but getting these filters to be super precise, so your audio sounds really good, can be pretty expensive. Yeah, it takes a lot to make analog filters precise, so that there's a lot you can do digitally to filter out noise, but we weren't able to figure out how to do all that completely.
And so we also wanted to implement fine-tuning ability. So yeah, when we were doing the trumpet sound effects pedal idea at first, we were going to have a pedal where you could essentially adjust kind of like how much these effects would be like occurring onto the signal. So we didn't have enough time to like implement that, but we were probably thinking in the future we would implement it using various like potentiometers or other sensors that could help us with that.
And finally, building an enclosure, because it's not the prettiest looking thing.
We're thinking maybe using Twinkies.
Yeah, in a Twinkie box.
Yeah. Any questions before we head over? Zooming down at our bench.
Okay, so we have a demo. We have we essentially have a button that will pass a 5-volt signal through, allowing it to switch between different signals. So right now, kind of laughably, I guess, this is, oh, hello? So this is our sound without any sound effects. This is not the distortion, but, hello? Okay, there we go. This one is a delay that essentially, obviously the sound is coming in afterward. We didn't include, I'll just do that. We didn't include the original sound coming through here. And that's the delay. Oh, and a lot of the digital filters were hard to implement as well because you can't have floating point numbers. And then this one is like this one is echo.
Yes.
Yeah, this one's an echo.
Sort of.
Kind of. It has a general effect. This next one is.
The robot voice.
Oh, this one's the robot voice. Is it?
It's supposed to be.
Okay. This one's a robot voice, and I think that's Flanger.
I think so. Yeah,
Well,
actually, you're right.
Yeah, this one's Flanger. I think we just missed the robot voice. They're a little hard to tell sometimes. And then if we go to the next one, so this is distortion. Hello?
We're running into some noises, I guess.
So this doesn't normally happen, but this is our distortion. I was actually going to play the trumpet into this one just so you could see kind of the distortion effect that we were maybe going to go for, but I don't know if we could play a trumpet in it now.
And
Yeah, no, that's not going to happen. And then finally, we are back to our normal signal. Yeah. So those are our 5 different signals that we have, and
yeah.
with a better ADC, it sounds much better. I promise you that.